like this one here. So for solving this here by factoring, the first thing we need to do is to get it equal to 0. Because for any higher degree polynomial function, so for these quadratics or anything bigger than it, we really need it equal to 0. There will be a case or two where we can get it equal to something else, but that's more of a special case. So the first thing we can do is, well, I need to move everything over to where 5r squared is. Since we already have r squared r in our constant term, might as well move it all over there. So we can subtract 11r from both sides first. And if we subtract 11r from both sides, we'll have 5r squared minus 55r plus 120 is equal to negative 30. Well, it's still not equal to 0, so we can add 30 to both sides, which will tell us that 5r squared minus 55r plus 150 is equal to 0. So we had to move both of those terms over to the other side and get it equal to 0 first. Now once we do that, we will look for actually factor. So greatest common factor first. And there's a greatest common factor between these three terms, which is 5. And if we factor the 5 out, we'll have r squared minus 11r plus 30 is equal to 0. Which will move us on to our two sets of parentheses with 3 spaces. Since the 30 is positive, the signs will be the same and match the sign of the middle term. So we'll have negative and negative. The factors of r squared, well, the only ones we have are r and r. Now the factors of 30, we have 1 and 30, 2 and 15, 3 and 10. 4 doesn't work, but 6 and 5 are 5 and 6. The ones we'll want is 5 and 6. Because if we were to check it, r times negative 6 would be negative 6r. Negative 5 times r would be negative 5r. And negative 6 minus 5 would be negative 11r. So that would be the correct factors. Now again, whenever we have 2 or more things multiplied together to equal 0, means that one of them has to be 0. So we're saying that either r minus 5 is equal to 0 or r minus 6 is equal to 0. And at this point here we can solve. So for the first one we would add 5 to both sides, telling me r is equal to 5. And over here we would add 6 to both sides, saying r is equal to 6. And that's all we would need to do. So for any of those there, we just need to get it equal to 0, factor, and solve. Now we could have just divided everything by 5 instead of factoring it out. Since it is equal to 0, that would work. Now dividing everything by 5 is really only if we're solving, because if we're actually factoring it and wanting this factored, we would need the 5. But since we're solving for the value of r, we could have just divided it out because we don't need it at the end in solving. Is that difference? But that's it. Questions on this here? Now, if you're wanting to make sure you don't get the two confused, you can just continue to factor it out and not do the division. Now, what we're looking at today are special factors. Now, one of the special, really the only special factor we'll look at for quadratics is this one here, the difference of two squares. A squared minus b squared is equal to a plus b times a minus b. So a squared minus b squared is equal to a squared minus b squared is equal to a plus b times a minus b. As I've said before, mathematicians are very brilliant when they name something like this here. I mean, I'm being a little bit sarcastic, because difference is just talking about subtraction, yes? Because difference of two squares, so we're subtracting two numbers that are perfect squares. A squared minus b squared, we're subtracting two numbers that are squares. And anytime we have that, it's going to be a plus b times a minus b. Well, an example of this here would be x squared minus 9. Well, x squared is a perfect square because it's x times x, something times itself. And 9 is a perfect square. It's what? 3 times 3. Now, we could write it out as x squared minus 3 squared. Well, our a and b would be x and 3. So we'd have x plus 3 times x minus 3. And that's it. Well, let's look at an actual example where it doesn't step it all the way through. So if we look at this here, we have x squared minus 25, yes? Is x squared a perfect square? Well, yes, it's x times x. So x squared would just be the same as, is 25 a perfect square? What time, is there something that multiplied by itself would give me 25? Well, yes, it would be what? 5 and 5, yes? And since they're being subtracted, well, this is a difference of perfect squares. So we would still have two sets of parentheses. The signs would be opposite. And that's it. It's a difference of perfect squares. And the reason that they make this one here special is because, well, the terms in both of them are going to be the exact same. We're going to have x and 5, x and 5. Because x times x would give us x squared. 5 times 5 would give us 25. Now, if we check the middle term, x times negative 5 would be negative 5x. 5 times x is plus 5x. Well, what is negative 5x plus 5x? This would be 0. Do we have a middle term in our starting equation? Do we? No, there's no x term with x, right? So we should expect the middle term to be 0. And that's really it. You ready for the next one? 4z squared minus 1. Is 1 a perfect square? Can we rewrite 1 as a number times itself? What's 1 times 1? 1, yes? So really, 1 can be written as a perfect of anything because it's a perfect cube because we can have 1 times 1 times 1, which is still 1. 1 multiplied by itself, no matter how many times, is still just 1. So it is a perfect square because we could say that this is 1 times 1. Is 4z squared a perfect square? Is 4 a perfect square? 2 times 2 and z squared would be z times z. So 4z squared is really just 2z times 2z. So is this here the difference of perfect squares? Is 2z squared perfect, or 4z squared a perfect square? Yeah, because it's 2z times 2z. Is 1 a perfect square? Yeah, it's 1 times 1. Are they being subtracted? Well, yeah, so this here would be the difference of perfect squares. So the signs would be opposite. And in the first spot we would have 2z and 2z. And the other spot we would have 1 and 1. And that's it. Because we could check it to see that it is 0, but that is it. Questions on this here? You ready for the next one? X squared minus 64. Is this here a difference of perfect squares? Because x squared is it a perfect square? Because it's x times x, yes, something times itself. How about 64? 8 times 8, yes? So how would we write this? Parentheses? That's it. Questions on this here? X squared minus 36. Exactly. X plus 6 and x minus 6. Because there's more technical ways we can delve into this, but really when we look at this, well, x squared is x times x. 36 would be 6 times 6. So we have x plus 6 times x minus 6. And that's it. Any other questions on this? 100 minus m squared. One more time. Exactly. Now it is very tempting, and I've seen it turned in, especially when we had problems like this here, as 10 plus m times 10 minus m. And because the m squared goes second in the equation, in both parentheses, the m is going to go second. Now we could have it written the other way, but we would have to flip it and really say negative m plus 10 times m plus 10. Because the m is negative, we could factor the negative out, really to say negative m minus 10 times m plus 10 to get to the same thing. All of these are the same answer. But it's a little bit easier just to leave m second in both parentheses since it appeared second or appeared last. Any questions on this here? Here we have 9n squared minus 16. Because 9n squared would be written as 3n times 3n, because the number times itself would be 3n and 3n. 16 would be 4 and 4. So 3n plus 4, 3n minus 4. Questions on this here? Let's add one in. or 27n squared minus 75y squared. Is this a difference of perfect cubes? Is there a number times itself that would be 20 or 27, or a number times itself that would be 25? Is there a greatest common factor between 27 and 75? Because there is one. Because will 3 go into 27 and 75? What's 27 divided by 3? 9. 9 times 3 is 27. What's 75 divided by 3? Mm-hmm. So once I pulled that greatest common factor out, now do we have a difference of perfect squares? Is 9 a perfect square? Well, yes, 9 would be what? 3 times 25 is 5 times 5, yes? N squared is n times n, and y squared is y times y. So this would really be 3 what? 3n plus 5y times 3n minus 5y. And that's it. So we could have variables in both spots, But as long as they're both perfect squares, we can rewrite it as a number times itself. This will still work. Any other questions on this here? Okay. We feel comfortable with that. Let's look at the last part. Evaluate a numerical expression. Use a special pattern or product pattern to evaluate this expression. Well, as we just said, a squared minus b squared is equal to a plus b times a minus b, yes? So 54 squared minus 48 squared, well, that'd be the same as 54 plus 48 times 54 minus 48. Well, 54 plus 48 is going to be 102. And 54 minus 48 would be? Well, now we can do 102 times 6. Which I believe should give you 612, yes? And that's it. Questions on this here? So we have 68 minus 62, and we want to find the exact value of this here, yes? Well, I think some of you have already started solving this and the ones after it, yeah? Because what are we doing? Well, you'd have 68 plus 62 times 68 minus 62. And I think some of y'all would then type in or have typed in 68 plus 62, yes? And 6, and then typed in the calculator 130 times 6. What happens if you type this in? What happens if you type 68 squared minus 62 squared in? Yeah, it would have given us the same thing. It would given us 780. And again, this is really just reiterating the fact that we could use this special product pattern, the a squared minus b squared is equal to a plus b times a minus b, to get to the answer. Now, if we didn't have a calculator and had to solve this, it would be a great way to do it. But if we do, calculator will do it for us. Any questions on this here? That's it. That is all we're doing.